Hello, my name is Alex, and you see I look pretty similar to this guy, right? So, and this guy actually thinks about some fancy abstraction, right? Which connects a number of things which normally shouldn't connect, like SignalR, micro frontends, Redux, and Redis. And so I'm going to talk about this abstraction, and we'll turn this into a sort of detective story. And by the end, you will learn like what's the abstraction and how all these things are connected. Let's start. Oh, by the way, you will also learn how to code real-time web apps, and in a pretty fancy way. Okay, but first we are going to talk about incremental builds. I guess all of us are developers and all of us know what are incremental builds, but I'm just going to quickly reiterate on that. So imagine you build a number of projects, like if you use .NET, and it probably looks like this, right? And these projects are built from files like services.cs. So once you change one of these files, technically it invalidates all the basically every dependency of this file, like services DLL, and in turn in cascading way it invalidates like everything, right? That depends on services DLL and services CS. And if you decide to rebuild, then let's say app.exe, then like these things are rebuilt, but let's say this file is just reused. Okay, so how this is relevant to real time, right? And imagine your whole app is a composition of functions. Like, let's say at the very top you have a function called render app UI, which calls a number of other functions and in the end returns, let's say, string. Each could return a picture or something else. Basically the definition or like description of UI you can somehow present, right? I mean, this assumes that it's either a textual UI or maybe an HTML, but anyway, I guess the point is not this, but that you can use the same approach to pull every bit of data, and in the end these functions if this stuff runs on the client, right, then it can make a server-side call and pull the data from server, and so on. Okay, now the question is like, why don't we build everything this way? And why? It looks simple, right? You can just build the UI and just tell what the data you need to bring in. And obviously there is a number of problems with this approach. Basically you will saturate every possible resource you have, so it wouldn't work. But before we it's too early to stop this conversation, and let's just try to draw a call diagram for a function like this, right? Basically the function computes the total for the cart in, let's say, online store, and so what we are going to do is we are going to get the cart itself, which has items. We will iterate through these items basically, and also we will get special offers, and basically we'll compute the best special offer for each item, something like this, and kind of compute the total by this way. So that's the diagram for this function. Basically you see it calls cards.get, get special offers, and so on. And if you think about this, like this diagram actually looks pretty similar to this one, right? Where you build projects and read files. So or like to this one, and you probably it clicks right now that you just saw this diagram. So if these two problems are very similar, then probably we can somehow use it, right, to use incremental builds to compute our functions faster. And here's how we actually can do this. So first, we, instead of recomputing everything, we may just pull the result of a previous computation from cache. Literally everyone knows about caching, so we will basically use caching, right? And even for like network calls, let's say, one of the problems was that we will saturate the network interface. We can actually use this. Technically, if we cache the data on the client side, right? And okay, so now let's also try to do this in such a way that we are not going to modify our functions. And there are lots of benefits of doing this by using this approach, but later I'll show why. But for now, let's just try to do this. So we are going to use so-called decorators. It's basically a higher order functions that take a function as an input and kind of wrap it, right? Or like you can imagine a decorator as basically something that injects kind of prologue and epilogue to the function. Here's an example of such decorator that could cache a result of a function that you pass here, right? So fn is a function that we pass to the decorator. As the output, we expect a function as well. And this is the definition of this new function, right? So first we compute a key that we will use, and basically we compose it somehow out of function itself. Let's say, I don't know, we use the name or something there, right? And its input. Now we check if the value for this key is stored in cache. And we basically just query the cache using double check locking here. So the reason we may want to use this part is that it doesn't make any sense to compute two values simultaneously for the same input here, right? Because if we are computing one, then when this block gets completed, then it will be immediately available for the second one, right? Now, okay. So, but in the end, right, we either get the value from cache or compute it and put it into a cache, right? And this code just shows how the decoration could work. Let's say we get the original function and kind of wrap it. Okay. All of this is kind of great, right? The problem is that the approach that I just shown works just with pure functions, and they also have to be deterministic, so there are not too many functions like this in real apps, and this means we basically can't use this approach, right? But on the other hand, technically we can actually try to make developers to write just these functions, and functional programming technically allows this, right? It's all about this, but there is also a way to do something else to allow us to use the same approach for regular functions, right? And let's try to do this. So now we are going to build a pretty similar decorator. You see the same signature, right? The difference is that it will be capturing dependencies. I'll actually explain what all of this means. and implement cascading invalidation. So I'll just going to show what all of this means right now. So as you see, like these lines and this block kind of technically look similar. The only difference is that instead of getting an actual value from cache, now we get a sort of box from cache, and this box allows us to do a number of extra operations. But like you see that, like for example, when I call use on this box, it technically should return the value, because like the result of this function like should be t-out. So basically this thing should return the value, right? The only difference is that it will also do some extra. Okay, now let's look at what's going on here, right? Basically we create a box here when we need to compute the value. We make this box current. Current means that like basically we use this construction to kind of publish a box in the current thread, let's say, as a current, right? And only once it's published as a current, then we set its value, right? Just compute the value. As for like everything else, it looks the same, right? And we call computed use here as well. So so what did you notice here? Like we use this thing, and basically this thing does a little bit of mysterious stuff, but more or less clear, like, right? So now what use does? Well, actually, like let's ignore this block for now and focus on this part. Basically use returns a value in the end, but before it returns a value, it finds the current computed, basically the current box that we compute right now, and adds a dependency to this box. I mean, basically registers the value that we use, or like the box that we use, as a dependency of the current box, the box that's currently computing. So like basically it means that if we like wrap a function, right, and it calls two other functions with certain arguments, then behind the scenes this thing will create dependencies for the boxes they create. Like the box for the top level function will depend on boxes of two other corresponding to values produced by two other functions, right? Now let's get back to this block. So basically this thing is also something like thread static variable, right? And we check if it's set here, then we call invalidate instead of doing this whole thing. When we call invalidate on the current box, and also return a default value, because like when invalidation runs, I'll show you what this means soon, values don't matter. So now how invalidate works, I mean this call. Well, basically it's very simple. We check if we are already invalidated, then there is nothing to do. But if we aren't, then we remove the value from cache, and also iterate through all the values that depend on us, right, and invalidate them. So that's cascading invalidation. I mean, this means that like if you basically validate, how to call it, let's say some ingredient, right, then the like assuming the rest of functions define a recipe, right, and we basically invalidate every intermediate product and product of this ingredient. And I mean, you can think of this as, let's say, if it's a production chain, right, then invalidation means like you mark certain thing as contaminated and try to identify everything else that kind of where it's used to also mark it as contaminated. But anyway, and we also call some event in the end. So that's the invalidation. And now the last piece, computed.invalidate, is a static function that we will create a disposable. Basically, it will create a scope during which invalidation is happening. And so basically we like remember the old value right here, and when it's disposed we kind of return it. So now how are we going to use all of that? So imagine we build a service that, let's say, has two operations. It allows to retrieve a product by ID, and let's say retrieve a list of well, I mean, it should be a list, I guess, here. So anyway, retrieve a list of products, right, which are featured. Now, let's say we want to update a product, and imagine that we somehow decorated these things, even though like I don't indicate this here. So basically, these methods are already decorated by this decorator that we just described. So how our update method would look like? Well, it's fairly simple. Like this part is where it runs all the normal job, right? Basically, it updates the product itself. But in the end, it starts the invalidation block, and here it just have to call every method with the parameters that like have to be invalidated. I mean, basically it has to invalidate every result of a call here that will be impacted by this change. And to do this, it simply has to make these calls inside this block. So like once you run this thing, right, inside, basically this thing is set. And once this thing is set, every use call enters basically this piece, which triggers cascading invalidation. And that's, I guess, literally it. So you see, we can like basically build a decorator that allows to do something like this. So let's say this is again the schema of dependencies of these results. So it's not like, I mean, you see that these arrows, they are pointing into different directions right now, right? It's not like these are calls, but these how result of these calls depends on each other. So let's say you invalidate this call, right? Then everything that depends on it gets invalidated. Then you invalidate, let's say, this thing, and everything you kind of that depends on it gets invalidated. And let's say if you recompute this thing, then basically like wherever is dark green is recomputed, but let's say this thing still can be reused. I mean, the result of this call. Okay, so it's more or less clear, right, how it's supposed to work. And now let's think of like why this thing is actually quite useful. So first, notice that every function decorated by this decorator, well, its results are cached, right? Dependencies are captured automatically. So like let's say if you use just functions that already return such things, I mean decorated, right, then you don't have to do anything technically, because like to invalidate its result, assuming that whatever it calls, like its results are properly invalidated. And it's also a transparent abstraction. Transparent in sense that like signatures and even the code of these functions, we didn't have to make any changes there, right? And they work technically the same. The only difference is that they get this caching behavior, so they basically return the result instantly if it's not invalidated, right, and available. Okay, and finally, like a brief note on delegates. Technically, yeah, they are not quite necessary. If you use dependency injection containers, then like you can just decorate your types basically with, I mean, you can just create descendants of your types, overriding certain virtual methods in exactly this way, right? Okay, now, like, whatever I described is not production ready, and it actually can be used in exactly like these. I mean, when it's designed like this, and in particular, it doesn't support asynchronous calls, right? It's not actually GC friendly, and basically, if so, anyway, I don't want to dig very deep into explaining why it wouldn't work exactly like this. My goal was to mainly show what the abstraction does, right, on a high level. And like, yes, there is a number of technical problems to solve, but yeah, believe me, all of them are actually solvable. Now let's talk about a couple other things that kind of related to this. So first, a kind of quick reminder on eventual consistency, since I'm going to talk about this. So what's eventual consistency? Well, I guess it's easier to define it as like, so what's worse than eventual consistency? And permanent inconsistency is what's worse than eventual consistency. And example here shows that, for example, Twitter doesn't have eventually consistent UI. If you open it in two windows and start clicking on like, dislike in them, you will quickly see that like the values will be, I mean, they will differ, right? And nothing will kind of bring them back if you kind of stop making actions. There is nothing like certain timeout or whatever when they kind of converge. And this is permanent inconsistency. The downside of this is kind of obvious, right? This means that like if you have a system with permanent inconsistency, technically you can believe its values. But I mean, it's usually sort of okay-ish for likes, but not quite okay for other things in UI and in apps in general, right? And by the way, here it shows that you can generate even -1 like by basically doing this. So anyway, now let's say you have two eventually consistent systems, and you kind of try to conclude which one is, let's say, easier to use, right? Or like easier to maybe maintain, consume, something like this. And you start to think, okay, like if so basically the question is like, are all eventually consistent systems equal? And the answer is no. The key, I guess, difference is, well, the percent of, or like kind of the rate of inconsistencies you see. And we're going to look at, so let's look at this from caching perspective, because caching implies you already, like any cache is kind of, I mean, any system with cache is eventually consistent at best. So let's say you just have a regular cache, right, and you can set expiration time there. So if you set a longer expiration time, then you get higher cache hit ratio, a desirable property, right? But on the other hand, you see more frequent inconsistent reads, which is not quite desirable. So you decide like, okay, let's decrease the expiration time, but like then yes, fewer inconsistencies, but lower cache hit ratio. And again, kind of something you usually balance somehow, right? And choose the, I don't know, something that kind of makes the most sense in your specific case. But like, here's what you want to have actually. Like, you want to cache stuff indefinitely and have basically the same, or like at least fixed maybe, or like zero probability of inconsistent reads basically, right? And so your chart should look like this. Now think of this caching decorator that we just discussed, and like it actually gives you exactly this property. So once you change something, it immediately invalidates everything that depends on this, right? Every output which is cached. Okay, so that's I guess the reason why I presented this example, and that's like the key difference between different eventually consistent systems. So basically you want to have, I mean, if you deal with eventually consistent system, then like the lower probability of inconsistencies you see, technically the better. Now the question is like, again, like why it's relevant to real time, right? Well, it's actually quite relevant to real time, and the reason is, so first, like what do you need for real-time updates? Well, since you can describe anything you produce, including the whole UI, right, or a piece of UI as a function, and we started from this, right, then so knowing that result of this function changes basically is equal to like what you expect from real time. I mean, you know that it's changed, you recompute it, right? And invalidation is kind of responsible for this, right? And you also need to recompute things quickly. And again, like this property with caching and kind of incremental build fashion is the one we already have as well. So finally, you need to send these results over network, but basically there are lots of ways to do this. I mean, we don't have to solve this problem, right? And ideally, as a compact difference to the previous state, but like I'll kind of talk about this in some other talk. So, okay, let's move on. So you know that there is a famous quote or statement on like that there are just two hard problems in computer science: cache invalidation and naming things. And I guess we kind of came up with a fancy approach to the simpler one, right? Now, speaking of React and Blazor, let's again kind of first a quick review of what Blazor is. So Blazor is basically .NET running in your browser, and it's like extremely highly compatible with .NET 5 or like I mean currently I guess like almost everything you have or like you can imagine works. And besides that, like besides that, Blazor components are quite similar to React components. Basically, in terms of UI framework, Blazor is basically a copycat of React. And shortly I'll explain why this is actually great. And there is also a Blazor server, so like Blazor can run in your browser or can run on server and deliver changes to the document using SignalR. Now, any technology has some downsides, and for Blazor, the main ones, again, in comparison to normal .NET Core, is that it's single-threaded, and I mean, it can run async code. It's not a problem. It's just like you just should take this into account, right? And worse, it's interpreted. So it's kind of slower than a normal .NET. The reason is that it kind of uses a special version of Mono that runs in an interpreter mode in your browser. But like in reality, you actually rarely have to. I mean, it's still fairly fast, and even on mobile, like it works pretty nicely. But like I guess all of us expect that with .NET 6. We will get ahead of time compilation and maybe also multiple threads in Blazor, because WebAssembly already got this feature. So it would be great actually in terms of, I mean, great improvement in terms of speed. And finally, I guess the download size is like pretty huge. I mean, still less than for Gmail for most of projects, but nevertheless, right? So if it's a problem for you, then you probably need to use Blazor Server. Okay, and here is an example of React component markup. It basically looks like this. As you see, the part here is like kind of looks similar to regular HTML, but you can also kind of call other components here, right? Like these two, or just regular HTML, create regular HTML elements, right? So this thing is actually transformed to this one when you transpile this thing with JSX compiler. And what's here is called virtual DOM. And shortly I'll explain what is virtual DOM, but like for like the reason I talk about this right now is that Blazor works nearly the same way. So the same markup in Blazor, it's like this one, right? And if you compile this thing, then it creates a method like this, and this method also creates virtual DOM. The only difference is that like previous virtual DOM was created in more functional style, and this virtual DOM is created in like using a builder. But like actually this like approach is better. And the reason it's better is that it allows you to actually compare this virtual DOM faster. Now, like, what's the comparison of virtual DOM, right? Well, basically the whole purpose of virtual DOM is to be compared with the previous virtual DOM for the same component. Like, let's say this is the previous virtual DOM for the same component. This is the current one. I mean, the one that just was kind of rendered, right? And when they are compared, Blazor and React, they behave kind of similarly. If there is a difference in HTML element and these changes are applied to actual DOM, regular DOM, and if there is a difference in component properties, then these components, like the components that differ, they are re-rendered. I mean, like, technically new properties are set, and in Blazor set properties is called, and then the component is re-rendered. I mean, state has changed is called, I guess. And for example, here the component is new, so it's created and rendered as well. Now there's one more example with, I guess, just HTML, but like the key point is actually, like, what's nice about Blazor and React is that they are these incremental builders for the UI instead of so if you think how we were working with HTML before React, I guess the most popular library, by far most popular library, was jQuery, right? And its whole purpose was to allow you to locate elements in HTML documents, right? And update their properties quickly and efficiently, right? Using as little syntax as possible. So if you think what's going on, then like, well, basically with React and Blazor, you just described a new end state, right? And the framework itself figures out what's different between the previous state and the current one and applies these changes. As for like what you used to have before this, you basically had to modify the HTML or like, and that's why React and I mean Blazor Mobile as well, and there's a React Mobile, they are applicable to generally any kind of normal kind of UI, I mean stateful tree of UI components that have to be changed to like display something new, right? Because like this approach is actually quite convenient. So and this slide kind of shows why also why it's quite convenient, because it's functional style of describing that like UI. I mean, you just describe your desirable state in every component. I mean, every component just tells like how it should look, assuming that like everything else, I mean, its state is set, right? And the framework itself decides how to update the actual UI that kind of sits behind so that it matches the state. So okay, I guess we came to a point where we looked at few different corners and found some connections. So like I mean, Blazor, React, they all implement incremental build just for the UI, right? And we also noticed that it's a useful property. I mean, this like incremental build with invalidation, useful property for real-time UI, for caching, and well, I mean, technically, incremental build is implemented, like we use it on daily basis. Now, like, is there something that implements all of that, right? And well, that's the reason I write this talk, and I mean I record this talk, and there is a library called Fusion, and I'm coincidentally the creator of this library. So this is the URL. It's free, so like completely free. I mean MIT license, and it actually allows you to do something like this. So you can basically create real-time UIs in Blazor. They work both in Blazor Server mode, in Blazor WebAssembly, and like you can see that it even synchronize, I mean, the state of like, so basically no matter how you kind of consume and share certain pieces of state, they are kept in sync. I guess look here right now, and I mean last chat message here should change as well, right? So you can click on any of these URLs and explore these samples and try to play with it. As for now, I'll just kind of try to quickly explain how it works. I mean the real library, the real code. So remember this caching decorator we were talking about. Caching decorator supporting invalidation. Basically, Fusion implements a version of this caching decorator that is production ready. And not only it supports async and like fully thread safe and so on, it also supports distributed mode and some fancy scalability features. So I'm going to briefly cover this in like the remaining slides. Okay, so everything in like, remember the box that was used here. So this is the interface that describes this box in Fusion. Basically, it has a consistency state which evolves like this from computing to consistent and to invalidated, right? And interestingly, the box is mutable only while it's in computing state. You normally don't see boxes in this state anywhere because they are not like yet kind of in cache. So you normally see boxes in consistent and invalidated state. And once it enters consistent state, or like any of these states actually, it becomes kind of semi-immutable because the only thing that may happen with it is like transition to invalidated state, but neither value nor error, nothing will change. As you see, like there is an invalidated event, then you can wait for it asynchronously. There is a method that triggers invalidation, and also a method that, like earlier I didn't show this, but there is a method that allows to recompute the like what this box describes. Basically, it kind of repeats the same call for which this box was created. And as you see, it returns a new computed, and that's why I say that like these things are actually semi-immutable. I mean, they're almost immutable in reality. And this diagram shows how they actually live. I mean, if you call the same function once, then invalidate it result here and calls it the second time later, then you get another computed. I mean, when I say get, you actually don't kind of get them as well. This is like the abstraction is transparent, but there is a way to pull the computed describing a certain call. I'll show this later. So anyway, now we are going to talk about a sample that's located right inside Fusion repository. That's the only app there. I mean, Blazor app, and I normally use it for like testing different UI features, but like interestingly, it implements a number of approaches to the well, I mean, basically it implements a number of different ways to let me actually show this to you. So this app technically has a single service called iTodo service, and this service basically just like, you know, to-do lists, right? So this service allows you to create entries in this list and like remove them, and this thing also updates the entry. And there are a few query style methods, like you can get the item, you can list them, you can get a summary for the current user. So session here describes think like HTTP session. It's just a Fusion session, and the reason there is a special type is that, I mean, technically it's a string, it's just a wrapper around basically the kind of idea of a session. But I mean, I ended up thinking it's a good idea to use a special type to represent basically a special kind of parameter. So what else here? And you can see that like this part of the API is like describes command handlers, right? And this, which means that like it's a CQRS style API where you describe basically all the parameters of certain operation through a dedicated type, like here. So I wouldn't kind of I'm not going to dig into like why it's done like this right now, but later I'll explain. And these are the types that were used here. So to do is basically a record with ID title, and is done like all of these records have an empty constructor, and so to do summary, just like two fields, right? Two properties, sorry, and like two commands, like add or update. Basically, it gets a to do, right? And remove, it gets just an ID of whatever you want to remove. Session is also passed through any command. So now let's try to implement the simplest possible to-do service. And we assume that this thing is going to run on the client, right, in basically Blazor WebAssembly app. So we are not going to, I mean, we will just ignore session here, and we will just use other parameters of all of these calls. So, and our store will be immutable list. Like, why immutable? Well, I mean, it's just because I guess I think if you deal with, like, if you create Fusion services, they typically have to be, or like you should assume that they can be called from multiple threads, and you either need some primitive like log or something to serialize access to wherever you use, or you can use basically built-in data structures that supports some kind of, I mean, which are basically thread safe. So here we are going to use immutable list, as I said, and let's say for try get, we will basically do kind of straightforward thing. We will just return an item with matching ID from this list. For get summary, we will simply count these items, right? So as you see, like these methods that this service has, I mean the compute methods, they are like, there's no any difference between like this implementation or like the one you would write normally. The only thing that differs is that they are virtual and marked by this attribute, and that's what allows, like basically what this attribute is what tells Fusion that this method needs this decorator we were talking about earlier. And finally, like, so how do we handle updates in this case, right? Well, it's fairly simple. So for now, let's ignore this part, right? And let's look at the rest. So you see that here we basically just apply changes as if we would do normally. Like we basically check if it's a new item. If it's a new item, then we give it some ID. So UL ID, I mean, you can read about what this thing is, but basically it's a kind of better alternative to GUID. Okay, but like this part is new, right? I mean, you would normally not have this one. So any method that changes data in Fusion, right, has to invalidate what it changed. I mean, if basically changes, if it touches some store that's external to Fusion, like in this case, this store is immutable list, right? So if it touches it directly, then it has to invalidate what's impacted. And to invalidate what's impacted, we basically create this block, inside this block we just call the methods that we want to invalidate. More precisely, we call these methods to invalidate their results for specifically the parameters passed here. And yeah, ignore here is just the way to tell that, so to suppress basically C# warning, because like it returns task, and we don't use this task here. And like it's also, I guess, kind of questionable, right, why we don't await for this thing. But so invalidation in Fusion is designed in such a way that, like, basically this decorator, it works in such a way that it performs invalidation always synchronously. So when it returns the task, the invalidation already happened, which is why it's safe to ignore it. I mean, the task is always completed here. So, okay, now how you basically make Fusion to provide these decorators, right? And it's fairly simple. You for any service collection, I mean, that's the default way to create dependencies and deal with dependency injection in .NET, right? So if you have a service collection, then you call on any service collection method called add Fusion, which gives you an object that allows to do basically to kind of deal with Fusion services. And for Fusion service like this one, I mean the one we just kind of wrote, we call basically this method to register it, and it will be in reality registered as singleton. So the only difference is that instead of this thing, there will be a runtime generated type that inherits from this thing and overrides these virtual methods that like require a decorator. Okay, now the question is like, so what would you see if you like run this stuff in the app with, I mean, in like you basically, if you use this service in this Blazor app, right, and you see that, sorry, moment, I'll show a couple things. So first you see that this is Blazor WebAssembly, right, and basically this UI component, it uses, I'll show you the code soon, but basically it uses this service, I mean iTodo service, and like right now we open a network tab, and basically network tab just shows nothing, which means that everything runs locally, basically re-renders, like you can make changes here, everything, like literally everything works, and even this to-do summary gets updated and it's always in sync, right? So basically everything works. Now the question is like, so okay, how UI components that you see here, how are like, are they complex? What's the code there, right? And we'll start from a simpler one. So to-do summary page. This component displays basically this thing, 0 done, 3 total, right? And so the question is like, how it updates, right? Well, first let's notice that this component is inherited from computed state component. Computed state component gets two things. First, it gets state property. State, there is an abstraction in Fusion called state, and basically state is something that has a method. In this case, it's a component method. It's an abstract one, like you have to override this one, and this method is similar to any other kind of method that's decorated by this decorator. So in reality, it returns computed, I mean backed by computed value, right? And it tracks its own dependencies. So once, let's say, this thing gets invalidated, then the result of this method gets invalidated. Second thing what state does is that, like, it basically implements this cycle when the computed that was previously produced for it gets invalidated, it makes a small pause. It's controllable, and you can override all of this. And after that, it recomputes it. So, like literally, this means that, well, initially this thing computes the summary by calling like to-dos get summary, right? And when the result of this method call changes, it again computes a new summary. And by the way, yeah, I forgot to mention that when state gets a new value, then, I mean, not here, but like when it gets a new value, it also triggers re-rendering of a component. As for like why value default is here, so state also has value property. It's similar to, let's say, task result. Basically, this property can, like, exception is treated by Fusion as a normal result type. So it's like basically it looks on it almost exactly the same way as on any other result. So it's cached by default. Just worth to mention that by default, any exception result gets invalidated after 1 second. So like you don't stuck with like getting exception because you got it once. But anyway, the point is that like this thing uses value default method property, sorry, and this property returns a default in case there is an error. So like basically if it's a default and it's null, default is null, right? So the type of summary here is like this thing, to do summary, and basically it creates an object with zeros, I mean record with zeros, and here we just display it. So like straightforward code, right? You see that there is no any update logic. So as I said, like technically, like all this update logic is kind of encapsulated in state and in computed state component. Now this is the diagram that shows like the kind of dependency chain you get here. Basically, this is the component. It has state. Usually, I mean, the computed here kind of, you may assume that it's produced by compute state, or like depends on it, and like this thing consumes get summary, right? So that's a sort of dependency chain. Now, so how to do page itself is kind of basically work. So it's also a computed state component. The difference is that like each state returns a list of, I mean, or like an array of to-dos, right? We do basically very similar stuff here. We just want to display an error. And as for like what's inside, you may notice that, let's say, well, this is not interesting. Let me show you some interesting pieces. So first, we use this to-do state summary batch component here, right? We just include it, and it's enough to make it work and update. So we don't do anything special for it. Similarly, and I'll show this soon, there is also a moment ago batch component that like shows this thing updated just now, 1 second ago, 5 seconds ago, and so on. Okay, and there is as for the like to-dos, basically these things, right? It just iterate through them and displays a component for each one of them. So now like what about its own compute state, right? And again, it's just straightforward code that like gets all the to-dos and recomputes couple properties, like has more and last state update time, and that's literally it. As for like now how load more button works, when you click it, it just increases page size and makes state to recompute. So this call means invalidate and recompute immediately, and like literally, like basically it's like invalidate and call this thing, because like if you don't invalidate it, then like this call wouldn't happen. But anyway, now the second thing is so when you create a new to-do, this code works. And again, you see that we just create a to-do and basically forward a command to command runner. Command runner is a helper for actually the next slide will show this. So basically you see that we create a command and send it to command runner, and command runner it's actually an abstraction that solves two problems. So first, in reality, Fusion has an abstraction similar to mediator. I mean, you probably know that there is a famous library called mediator, which allows you to create command pipelines. So in Fusion, there is kind of its own version of mediator called commander. It's not dependent on Fusion in any way. It's kind of orthogonal to it. It's just a separate library, but Fusion uses it. I mean, higher level Fusion abstractions use it. And in particular, it's used to implement CQRS in Fusion. So, and that's the reason why every command has its own type. Basically, commander is what discovers command handlers and implements dispatch and invocation of the whole execution pipeline. So, as you see, here we invoke basically a kind of wrapper of commander, or basically a helper type that in the end pushes command to command runner, to commander, but it does some extra. Basically, it captures an error if it happens and kind of just suppresses it. So it suppresses the error, right, but exposes it through its own property, and this property is usually used in the UI to show an error right near the component, that let's say right near the button you clicked, right? And the second piece is like this one. Basically, if it knows that the component that just kind of invoked it is a stateful component base, then it calls an additional method on it called apply user cost update. And this thing is interesting. So technically, when invalidation kind of reaches the client from server, it's so anyway, I guess I'll skip this thing for now. I'll just explain, quick explanation will be like this. So since this update is caused by the current user, there is no need to have any delays that usually tick before it's displayed. And basically this thing cancels these delays. So it's not like it kind of pulls some data or something from server. Basically, it just awaits for the invalidation and then nullifies the delay. Which is completely logical for the update that was caused by the action of the current user. And that's it. Okay, now finally one more component. So this moments ago page, basically the component that displays this line, the update happens 5 seconds ago, 6 seconds ago, and so on. So how it works? It's probably the simplest one. It uses Fusion Time service, and Fusion Time is one of built-in Fusion services that provides methods like get UTC now and stuff like this. Basically, it provides method that retrieve time, and they automatically invalidate in 1 second by default. But also there is a method called get moments ago for you can pass a value there, and it will return a string that will auto invalidate once it basically has to be changed. So literally this thing just calls get moments ago, and this string is its state, and it literally just displays this thing, right? Okay, now and this built-in service, iFusion Time, basically that's how it looks like, and this is the method that we are using. Okay, now an interesting question: can one Fusion service call another Fusion service, right? And the answer is not just can, it actually should. The reason is that and the reason why it's actually good is that you don't need to do any invalidation in this case, right? So that's why Fusion offers a number of built-in services. One is Fusion Time, you already saw this one. Then there is also a key value store, and there are 2 implementations of this right now, but you are free to add your own. There is also a sandboxed key value store. I'll quickly talk about this right now. And services that are used for authentication. So key value store is like literally a key value store. The only kind of maybe a little bit unique part here is that it's hierarchical. Basically it's like file system, you can think of it, and so it allows you to retrieve basically key suffixes in any prefix, something like this. And the methods that modify it, they are supposed to invalidate results of, let's say, this thing when it's necessary. Now, what's sandboxed key value store? You can think of sandboxed key value store as a view to send to normal key value store, but kind of constraining it to just a certain folder, like user folder. And basically the difference between this interface and this one is that session is passed here to like any method, and I mean it has session argument, and this argument allows to resolve user and kind of implement all the constraints. And yeah, there is an implementation for this thing in Fusion that truly kind of limits you to a certain prefix for each user. Now, why this thing is necessary, right? Well, the assumption is like this thing can be used on the client to store some client-side data on server, and like apparently you can share this thing on the client because like literally it provides access to like everything, and basically the data of other users too, potentially, right? So sandboxed key value store is basically sandbox over key value store. Now, so what we are going to do now is basically we will implement to-do service. So earlier we were using simple to-do service, right? Now we are going to implement normal to-do service that will use sandboxed key value store. And let's just see the code, right? How such service would look like. So as you see, it uses sandboxed key value store, and our service, it's also one of built-in Fusion services. And again, like in the beginning, there is a call we are not going to talk about right now. I'll cover it later. But as for the rest of it, well, we get user, current user, call this method to throw an error in case this is a guest or like not authenticated user, right? Then we get two keys basically by calling, I guess, this method and this method, sorry, two names of keys. So we basically get to-do key prefix, so like we basically get keys that are named like this, right? User, then user ID, to-do items, and so on. And we simply remove both of these keys here. Now the reason is like, oh sorry, the question is like, why do we have to remove two keys, right? Because like we want to remove just one to-do. So you may notice that key value store that we use, it has count method which allows to store, which allows to count keys in a certain kind of folder, right? And it's supposed to work faster, and because of that, since we want to implement get summary, and get summary need to return to do count and done count. So for done count, we will use a simply dedicated prefix, and we will store just like, let's say, Boolean values that are just true, true, true for each done, and nothing for the items that are not done. So basically we kind of duplicate this information just to use count method here, right? And speaking of this method, you see that this is a compute method, so the one that will be decorated, and we again like get user here, check if it's authenticated, right? And then we just count items. So we basically produce count and done count and return a new object. You see that again, it's a normal code. There is nothing like, I don't know, special for real time, wherever. And this is also nearly normal. Well, it's actually like completely normal code except the first line. So now I guess like the question is, will it work, right? And you see that like in this case I enabled option 2. So previously we were using so let me quickly clarify what's going on here. So we this is a program CS of UI project. UI project is what runs in Blazor, right? And this code configures dependency injection container here. So previously we were using simple to-do service as implementation of to-do service. Now we commented this out, enabled a bunch of other services in memory key value store, sandbox key value store, so that we have this iSandbox key value store available. And then we add compute service for to-do service as to-do service. So the code that I just shown you, it will work right now. Okay, so I guess interesting question, right? We replaced like implementation completely. Again, will real-time stuff work? And I mean, again, we open a network tab here, and like basically the fact that UI works tells that like all these invalidation notifications and stuff like this, it works perfectly, because like you probably noticed that there is no single kind of piece of if you clicked something, then update logic in the UI, right? So if UI works, then like everything like literally works here. Okay, now so let's kind of try to draw what was going on here, right? So let's say for to-do summary page, we were calling compute state, which was calling get summary of to-do service, which was calling sandbox key value store, namely two count methods here, right, for two prefixes, and they were calling in memory key value store, right, and also this thing was calling auth service, and that's how it worked on the client. I guess an interesting question is like, why this thing is blue so others are red? Well, the fancy answer is this service was actually a server-side service, and when I told that like in Fusion it allows you to basically use these IComputed and decorators. I mean, they can be distributed. That's the kind of situation we have right now, and even though it's not quite straightforward from the code. So but first let me quickly explain how it works in case with Fusion. If you remember, then there is an interface for the box that we use, right, called IComputed, which has consistency, state, value, error, and let's say an event called invalidated. And you may notice that it's actually fairly easy to create a version of this IComputed that is simply a replica of another IComputed. All you need is to basically just copy the value, consistency, state, and also propagate the invalidation event. It's like you subscribe on source invalidated event, and when it happens, you are going to invalidate this thing. So if you, I mean, this stuff of course like can work only locally, but if you implement something to deliver this thing over network, then basically you may have a replica of IComputed that exists somewhere on another machine, and invalidation will trigger there as well. So technically you can build the whole graph of dependencies based on it as well. It basically will literally mimic the computed value on a remote machine. Now that's not it actually. I mean, in terms of how it works in Fusion, it actually goes a little bit further, and here is a description of regular web API call, right? So normally your client calls a web API controller, right, and throws some request there and gets a response. One request, one response, right? Technically, it doesn't seem there are any problems. It's just like kind of normal way to do something, right? But think of like, let's look at what Fusion does instead. So Fusion allows you to create controllers that act normally if you call them like normally, but if you ship a special header, it's called xfusion publish, then in response it will return you again like a regular response, but will also capture a computed value that kind of sits behind this response and so-called publish it. Publish means it will basically track its invalidation, and when invalidation happens, it will deliver a message to your own client via WebSocket channel that this value was invalidated, something like this. Now the question is, so you see that like technically it's not like way more, it's basically like you make one request and get one normal response, right, and one sort of side channel response potentially in future for the invalidation. The question is like why it's even, I guess, important, right? Why this stuff is useful? And the answer is, well, if you think then about the like what you can do with this knowledge, then like you immediately discover that from the moment you get a regular response till the moment it's invalidated, you can simply reuse it, right? So let's say if you have a proxy here that like you call as usual, and when you call it, normally it throws a request to a remote server. Then like if you keep track of parameters and stuff like this, and basically until the moment this like previous response is invalidated, you can technically serve the old response and you don't have to even call the remote server, right? So this thing is resolved locally, and basically that's how you kill the chattiness with, I mean, RPC chattiness with Fusion. And for the sake of clarity, like in Fusion it really works like this. So to share something over network, I mean one of basically services like iTodo service, you can share it over the network by creating a controller. It's regular API controller, you see, which I mean has regular route and like HTTP post, HTTP get, and so on attributes. The only difference is that its method that returns a computed value, I mean in the end, like try get for example, like all of such methods actually, they also have to be decorated with publish attribute, and also this attribute is important. So as for like what it has to do, it should just forward the calls to the same service that it kind of describes, and that's it. So now the question is how you consume this thing on the client so that Fusion kind of provides this extra logic that eliminates calls, right? And it's fairly simple. You basically describe a matching client for it. So the reason why you have to do this is like you see that like basically this thing maps .NET API to Web API. I mean it basically maps this method to technically some string and like HTTP method, right? I mean the name of this, like, so it will be post to add or update endpoint on the API, then to do, then like basically add or update, right? So you need to do a reverse operation on the client and basically tell how you map .NET type to the controller. And Fusion uses REST-easy for that. I mean, this is like a real REST-easy interface and the REST-easy attributes. It uses this client under the hood, but like in reality, what you do is that you tell it, so similarly to registering compute services, you register replica service here, and you tell it to expose this thing as this thing, and that's it. So like all the magic happens basically somewhere in between. Like it generates a runtime type that implements this logic with call elimination, and like moreover this service will be also compute service, so like you can have dependencies on it as well. Basically it will behave exactly like this service on server, but will work on the client. Just calls will take a little bit longer unless they are cached, right? I mean, their results are cached. So, and yeah, it's a sort of proof of this. So for two samples, for the samples that I referenced previously, you can go to Swagger URL and basically see all these endpoints, and you can even trigger them, and you will see that like if you have the same UI open somewhere, you will see changes. So, and I guess the straightforward benefit of this is that it's an API first design, which means that like whatever you create for your Blazor client will be also available for like literally any other potential user of this API. I mean, third-party services or like wherever you can imagine. Now, how it's going to work then in this case, right? So again, let's look at to-do summary page with its state, right? Then, so this is the proxy generated on the client, like which will talk with controller, which will talk with which will forward calls to do service on the server, and then like the same chain that you already saw. The only difference is that like here we are going to, on server this time we are going to use dbk value store actually, and dbout service. Now yeah, if we extend this diagram a little bit with like what happens under the hood, then basically there is a side channel that delivers invalidation messages and does a bit more, but like you never see it normally. And this also explains why Fusion works nicely both in WebAssembly. I mean, why you can use the same UI code in Fusion in WebAssembly, like working on as WebAssembly basically implementation and as server-side Blazor implementation. Well, what Fusion does is that like basically it makes these services, I mean, it completely kills chattiness of such services, and they never kind of call server twice for the same thing, assuming it's still cached on the client, right? And moreover, by the way it's designed, it actually like everything that's displayed right now is definitely cached on the client. So, but interestingly that like on the server side, right, if you use server-side Blazor, then you can consume from the same code, just the same service directly, because all of them implement the same interface. And that's like, so that's how it works. That's how you can, that's why you can switch in any of these apps between this Blazor server and Blazor WebAssembly mode. So that's the diagram that we had in like previously, right? And that's now the diagram of a setup we are going to have right now. Basically, we'll run all these services in server side, on the server side. So I uncommented option 4 right now, and basically you see that like it uses Replica Service now for to do service and uses to do client. And so now if we yeah, so let me make a pause. Basically there is a debug output there that like I just added to to-do page, which shows if this to-do service is iReplica service and iCompute service. So normally if you use Fusion service, then it like the service can be sorry, it's an iCompute service. And if it's a client of remote service, then it's also a replica service. And you see that right now both return true. What else here? Well, I guess the other thing is that, yeah, so that's so the logging happens from compute state method in to do page. Okay. And by the way, you see the breakpoint here, right? So since we run Blazor WebAssembly right now, it wouldn't be hit. I mean, it's right there, and it just doesn't debug Blazor. And yeah, let's see like what's going on. So network tab right now, it started to show that like it actually makes remote calls, and when we like change something, basically these values match, right? And it works. Now I guess what we are going to do is we are going to open a second window right now. So now we are, let me make a quick pause. So right now we store all the data on server, right? And since, I mean, previously we simply couldn't open two windows because like all of them would have a local state and they wouldn't be in sync, right? There's nothing to sync. But since right now the kind of very final services live on server, then like all the invalidations should kind of propagate to like every window that's open if it's the same user. And you see that, yeah. So you see that like if I change something in one place, right, then it changes in another. Moreover, right now we can switch one of these windows to Blazor Server mode and it will still work. And whoa, by the way, yeah, you see that breakpoint triggered right now because, I mean, the breakpoint works just on the server side here. And well, this means that, just a moment, this means that, yeah, this code really runs on server right now. And if we go to debug output here, you see that, so as I said, to-do service that's used in to-do page, now it's not a replica service but still a compute service. Basically it means that it's like a real server-side service. Okay. So is there anything else? Yeah. Yeah. I guess, yeah, we can continue this stuff and yeah, so it syncs the state no matter what. And yeah, it's worth mentioning that it actually syncs every bit of a state. So if you sign out in one window, you signed out in another one, and sign in works the same way. You can try it in like any other sample. It's like, yeah, it works in sync. So right now, by the way, so what I just did, I copied session ID and run a console client for this sample. So this client requires some session ID to work as well, and I am just going to paste it so that I basically use the data of the same user. Okay, come on, continue please. Okay, so yeah, I pasted it, and you see that even console client for the same service, it's basically kept in sync. I mean, to do summary here, it's like it's kept in sync in console client as well. And for the node, that's all the code that basically does this. So all we do is, like previously we captured the compute that kind of backs this get summary call, right? And there is a loop that waits when it gets invalidated and calls update. That's it. Okay, let's move on. So what I just shown, sorry, what was just shown, right? That like you can literally create graphs of these computed values, right? And like they can live on different hosts, like can be created by different services, and it works. I mean, with dependencies, with invalidation, everything works. Now, there's going to be a final example that shows how this stuff works. Let me actually. So normally you want several replicas of each service, right? If you want to scale them, and it's interesting that Fusion provides special support for this mode as well. Let me just run it. So I decrease update delay to 0 here, just to show that like these updates are instant. It's not like even if you. So yeah, and what I'm going to do is I'm going to basically run 2 processes on 2 different hosts, right? And I'll open 2 browser windows. Each of these windows is connected to its own process. So you see that, like, just a moment, yeah. So yeah, you will see it soon. So the left window is running a process for a 5005 port, right? Sorry, and yeah, the browser window is kind of connected to this process, and for the right window it's connected to basically another process. Now let's kind of play with it, right? So you just notice, right, that once I signed in here, sign in happened here, then so basically wherever changes I make, they are kept in sync. And if I click, yeah, like 6, you see, right, a lot more. Basically it's 100% in sync. There are no delays because like I nullified default update delays, and I guess now it kind of becomes completely tricky, right? I run 2 processes with 2 web servers, like there are, like everything is different there. So how do they sync the state right now? Oh, and yeah, you can also switch one of these 2, like Blazor Server, another to Blazor WebAssembly. It still works. So, well, so now I'll explain like what actually this code was doing. So normally, instead of implementing these invalidation blocks somewhere in the end, you should implement them like this. And that's why previously this call was always just kind of returning here, but like because I was not showing this mode. But like this is the final version of I mean, this is actually another service, but the final version of to-do service actually like, I mean, technically it doesn't even need invalidation because key value store, the service it uses, already runs it. But if you look into the code in key value store, like db key value store, wherever, you will see these blocks. So now, like how it works? Well, basically I say that Fusion uses CQRS, and in reality each of these processes logs these commands, and it basically uses something like outbox pattern when it logs the commands in the same transaction. And other processes basically pull these commands from the log and listen to notifications that kind of log tail is updated. And interestingly, like the reason, like, or like what happens when they pull these commands, well, they run them but in invalidation mode, and in invalidation mode means actually inside this block. So like literally when you when the command runs on the original host first, it runs when this thing is off, and basically this code is executed. The second time it runs when this block is, the invalidation is on, and then this code runs and basically the invalidation happens. But that's on the original host. As for every other host, they run just this block. And so that's how the state is kept in sync. I mean, like, basically that's how you can run a cluster of machines and still run invalidation on all of them. Okay. And as for the, and yeah, these are just some examples of services that use entity framework and DB context, but like ultimately they don't differ from like what you saw previously. And this is an example of service that basically pulls data from many different, like many other services, and like still kind of this value is properly updated. You can see it, yeah, in this sample. So I guess that's mostly the last topic I'm going to talk about, and kind of some conclusion slides. The performance of caching, or like this approach to caching, right? There is a test in Fusion which basically runs this method from multiple threads, and it does it in two ways. In one case, this is just a normal method which basically does exactly what's described here, like literally pulls the user from DB, right? No caching. And oh yeah, this thing actually, it's not a factory. I mean, it's so it reuses DB context, but still. And as for the second version of this test basically runs the same logic but as a Fusion method, so it kind of caches the output, and it runs multiple readers, one writer, and compares the result. So the difference in terms of performance, but that's on pretty big, I mean, like it's on Ryzen, basically 48 core Ryzen, sorry, 24 core Ryzen, yeah, 48 in hyper-threaded mode. I mean, so 24 hyper-threaded core Ryzen. So the speed up for SQLite is 16,000 times. The speed up for in-memory EF provider is like 1,000 times. So it's huge actually. And interestingly, if you also create a web API for basically the same method, I mean, you literally will expose this method via web API and also the method that modifies user via web API, then like, so if you use Fusion service behind this web API, you will still get 6.5x throughput. And if you use Fusion aware client as well, it's, I mean, basically it's the same way win in terms of like, so it's like for in-memory EF provider, so 1000x, even though you have basically an RPC here, right? And crazy, it's not real RPS, of course, because it basically kills the chattiness and extra calls on this client, but still. So let's say, I mean, we are talking just about like the minimum speed up you saw right here, and like how this tiny speed up looks like. So you know, probably you saw this famous video when Brie Larson is playing Beat Saber, and it looks like she's doing pretty well, right? Now I guess let me check the volume here. So now let me show you like how actually like one of the best player plays this game. So, and if you look at this number, right, basically it's maybe a little bit more than 10x to what she does. Okay. And the reason I showed you I showed you this video is that, like, well, every limit exists just to kind of break it, right? So let's summarize what you saw. So first, Fusion is kind of fancy replacement for Redis, Memcached, and so on. And it provides a few interesting advantages. First, you get almost always consistent cache, right? Second, it's a local cache, which is like literally 1,000 times faster, probably, because it kills. I mean, there's just no need to do network calls, serialization, deserialization, and moreover, you can reuse the same objects that you cache. I mean, if you like, let's say, cache a tree composed of small objects, right? Then like basically, if small objects are cached, then tree is a sort of small addition, right, to these small objects. Anyway, and finally, like everything is built incrementally. And by the way, Fusion supports swapping to external caches. So second slide is, well, let me show you, like, yeah, what's here. So if you compare Fusion with approaches to create real-time apps with SignalR, then you will immediately discover that, like, first of all, Fusion takes care of publication and subscription. Basically, when you call these methods and get some results, you subscribe to their changes, and Fusion automatically unsubscribes, and so on. Basically, does all of this under the hood for you, and you just shouldn't worry about that. Every event you normally send via SignalR is replaced with a single event. That certain result is invalidated with Fusion, and yeah, it guarantees eventual consistency. As for like benefits in terms of code, well, again, you start to write more functional code for basically, I mean, you describe how to build stuff instead of how to update it. And notice that like you don't have to write separate kind of update code on the client. So like normally you have to update on server, update on every client, and like this is a different code, right? In case with Fusion, you don't need this. And like I think this is also a good comparison. Basically, like it's like what it offers is similar to what React offers in comparison with jQuery in this sense, right? Well, and yeah, any API, any Fusion app kind of API is API first app. Plus you get like tiny response time due to this, like everything is cached nature, CQRS, multi-host mode, custom update delays. Basically your app is kind of high load ready from the very beginning, right? And as I said, it's a single abstraction everywhere. Now I guess I frequently get questions like how this stuff is compared with gRPC, and I think that's the slide that describes this perfectly. Basically, if you think what's more important, either to ask questions faster or just to don't ask what you already know, I would say that the second thing is kind of more important. I mean, you probably need to worry about the second thing first, and then like worry about the speed. So yeah, and Fusion, by the way, doesn't support gRPC. So far, no plans to implement it, mostly because, well, it's .NET versions as well. The libraries that are available, they don't support open generics. So, and Fusion needs this stuff. And but there are plans to support message pack and basically probably message pack on top of gRPC. So in the end, it's going to be fast. It's actually already kind of quite fast. As for the UI frameworks, so here are a few slides. I'm not going to focus on all of them. Basically, they just show that well, all the UI patterns or like they are kind of similar. I think the more modern one is Flux and Redux, right? And so kind of with Flux, your views create actions which go to a dispatcher, which kind of notifies stores apply actions and kind of notify view, right? Then for Redux, what it changes is that like it basically instead of dispatcher, it uses reducer, which kind of recomputes the store and applies the change there, right? And finally, there is an older MVC. So there is actually no action here. Usually it just calls controller methods, but if we imagine that there is an action, then you will notice that it's kind of similar to Flux, in sense that there is a model instead of store, which and I think the difference is that, like, usually controller notifies you about the changes in model, and in this sense it sucks, right? But if you use MVC with knockout or MobX, basically with models based on observables, and it's I think you can kind of also safely call this thing MVVM, right? Then it's going to be very similar to I guess Redux. The difference is that, I guess the key difference is that the model here is mutable, and with Redux usually it's immutable, but that's nearly it. So now what Fusion changes here? Well, interestingly, Fusion kind of kills the need for reducer and kills the need for like controller or something, because I mean, technically actions are commands. Commands are dispatched by commander to command handlers. Basically, these command handlers apply updates and trigger invalidation, and kind of invalidation reaches the view, right? And if we remove these kind of invalidation arrows, then basically it looks like view similarly kind of queries the data, and because it has state, it gets notifications that pieces of data are updated and have to be kind of requeried. And so like I guess what I'm going to show here, or like what I'm showing here, is that like all these patterns are similar. The interesting part about Fusion is that it's probably the only option that kind of allows you to create services that run some actions both on the client and on the server, and like even connect these services together so that they call each other, and it still works with different commanders, and like, so anyway. And yeah, you don't so with Fusion what's important is that you actually don't need any UI framework, because this model is kind of already I mean, if you just add this state to a view, then like every other component is already there. So again, what are the benefits, I guess, versus other UI frameworks? I mean, you just don't need like reducers, stores, and like even separate models. In some sense, you can use all the stuff that's available on server. You don't need observables, no notifications, and like any stuff like this. Basically, it's much simpler, right? Oh, I think one important part there is that you notice that all these Fusion UI components, they are like, they just consume the service that provides them with the data, right? So they are extremely loosely coupled, and this is why this is a good fit for like micro front ends and architectures like this. Okay, finally, I guess the question every Blazor developer asks, like what to choose, right? Blazor Server or Blazor WebAssembly, because usually it's hard to support both. So Fusion right now is, I guess, the only framework that allows you to support both these things and have the same UI code. I mean, without single extra line of code written to support both of these things. Well, I would say it's sort of just a half true, in sense that like you still need to, so to to support Blazor server, you don't need to create controllers, right? And clients. I mean, basically these template files with controller and client. But if you still want to share the API, so basically if you want to have an API first app or just an app with API, right? And you would still do that. So in some sense, like because you will probably anyway do that, you get well, basically Blazor WebAssembly for free with Fusion, or like you can think that you get the API for free and get both these things, right? Okay, so now we are kind of getting back to the picture you saw in the very beginning, and probably it's clear right now that Fusion kind of connects all these things in and either kind of replaces some of them or just integrates with some of them really nicely, or like for example with Blazor, right? Or for web APIs, it's also an interesting thing. And somehow, yeah, basically this abstraction is so universal that it kind of, I guess, overlaps with almost any technology we have to use right now to build the apps. Okay, and I guess that's the interesting piece about this, and that's something that makes me think that at least it's a pretty useful thing in terms of unification. So now I guess it's interesting to think what are the downsides, right? And I guess in terms of money it's free. In terms of resources, it basically kind of shifts a lot from CPUs, right, to your memory. I mean, not your, but the memory of your virtual machines, or like wherever you use. And in exchange, it provides you with this like almost instant response time and like all the real-time features. As for the learning curve, I would say it's comparable to task parallel library, or this basically async await stuff in .NET, in sense that it's really similar, I guess, in terms of complexity, and also with some quirks and basically tricky pieces that you will end up learning eventually. Similar tricky pieces exist in TPL as well, and I guess that's it. So yeah, learning curve is kind of a little bit, I think, steep anyway. But I think the good side is that if you need something for real-time UI or robust caching, then Fusion is probably like the best option you have. Now, why all of this matters, right? Real-time, and well, I mean, first, I guess it makes sense to think why we even write apps that don't have this real-time feature, and probably this is done right now just by historical reasons. But the real answer is, I think, and it's not just about real-time, but more about Fusion. So if you have a technology that allows you to move faster with many different things, and it's actually like, I mean, technically it's one technology that kind of replaces the need for many other things, right? It allows you to evolve faster, and in today's world, I think this is a key property for like any startup, any company. The one that evolves faster kind of wins in the end, and I guess this is a proof, right? Sort of proof. Okay, and I think one other important thing is that the competition in IT sector increases. So if you hope that you will be able to kind of stay on the old technology forever. No, this is not the way to kind of even survive right now. Okay, and I guess that's it. Thanks for watching, and please feel free to send me any questions. The best way to do this is to just join this Discord, and what else? Yeah, that's the link to repository of Fusion. There is a separate repository for samples, and of course I would love to see you here, and I would love to answer any questions. Thanks.